So before we start, I really would like to ask you and raise your hands if somebody of you are here developers, so that just to understand which type of speech better to say. Great, we have several ones. Okay, amazing. So, and whom of you, doesn't matter are you developers or not, actually has any relationship or know about what Polkadot is, the .sum ecosystem? Ah, great, that's good. So I have here sometimes developers and guys from Polkadot and the other guys just like blockchain. Okay, so what I would talk about is something new and unique that's called Gear Protocol. I'm from the Gear Technologies company. We developed this. What's that? It's actually based on substrate technology, something that Polkadot developed to deploy blockchains out of the box practically. But we added several features that could make it faster, easier to do. So it could be deployed later on as a standalone network, or could be part as a parachain to Kusama or Polkadot. So Gear Protocol is based on three main features. First of all, the actor model. Second, WASM, or Web Assembly Virtual Machine. And third, the persistent memory. Now we'll explain why this configuration of three main things gives an amazing result. So first of all, let's start with the actor model. The actor model is something not really new in the computer science space. It's used for high parallel computation to parallel processes in high load things. So, but never practically used on the blockchain. We decided why not to put it here where we need a lot of transactions and we want to make them parallel. So using this model, practically everybody inside the blockchain becomes an actor. Doesn't matter, are you a program, or are you a bridge, or are you a user? So practically everybody is the same for the blockchain. Everybody has an account, everybody has the option, and they just start communicating with each other through sending messages, which automatically opens an interesting thing, that you can make an easy way a decentralized messenger on top of the blockchain without actually having to develop a lot of things, because it's inside by design, the sending messages between the users. And the second point is everybody is equal in the blockchain. It could be easily done that one program can generate a new program inside the blockchain without any user interaction. So practically backing back to the messages system, it allows you to make an interactive approach to the smart contracts, meaning that let's say you can send a transaction to any other person and add a comment to that transaction. Or you can just send a comment to him without any problem. The next thing, WASM, Web Assembly Virtual Machine. It's actually practically the standard for the new blockchains. It also was developed by Google, Oracle, and a lot of other folks for actually doing something that was working on the web to make the idea of the web and computation faster. And then Gavin Wood, the founder of Polkadot and ex-CTO of Ethereum, understood that the best way actually to use a virtual machine would be to use it into the blockchain. And WASM became now the golden standard for the new generation of the blockchains. And the persistent memory is something that we added there to allocate and deallocate memory into the programs, which will allow us to make more efficient constructions. All this generated into three possible networks. The first one that we are going to launch, it's called Vara. It's a standalone network. It will be practically launched at the end of this year. We're planning and aiming to do the first stage of launch as a proof of authority on the 15th of December. And then there will be different other options to launch as a Polkadot and Kusama parachain. So the first network, the Vara network, it actually has all these amazing features put in together into one blockchain, a standalone blockchain that would be the fastest one as a proof of stake consensus. It allows a parallel computation and parallel processing. Why it's good and what it gives to you? So first of all, by using the actor model, we have an asynchronous messages. What that happens is that if you have all the blockchains mainly now, they're working in a synchronous manner. Meaning, if you have to do an operation, let's say A, then get an plus B, and then get an input from somebody there located at C, if all this comes into the same block, into the same moment, then you will be able to do it. If you have to wait an answer from somebody else, then this computation is not possible actually in the synchronous blockchains. With us, we can do it quite easy. We just do A plus B, put it in the first block, then wait the answer from C, and then the nearest block we close it and go away. That means that your operations could start building really not just smart contracts that has 2 or 3 different ways of answering. It actually allows you to build programs on blockchain. So you can start building microservices on top of that, which gives you a totally different freedom of computation and operations that could be done on the blockchain. That actually opens a second interesting thing. It opens an idea for the gamified solutions where you can easily start building games that will be totally on-chain games with an interface and user play experience much nicer and better, because you don't need to wait each user to actually make a move, then compile everything and get the result. Each user could be playing by himself, and at a certain moment you will just check the results of what's happening there. So the next steps that we are having, Vara is actually, as I told you, is a multi-stage launch. We'll have the first stage, then the back bounty program, then we have several other interesting features like an ambassador program launching and stuff like that. So why Polkadot and Kusama? Obviously, when you have a standalone network, which is really good, but you still don't want to be isolated from the whole socium and the people around. So the idea of the Polkadot as a layer 0 was actually to bring all the blockchains together so that they can communicate with each other in one big network. So that's why it's actually the same idea as Cosmos also has. But the difference with the Polkadot and Cosmos is that Polkadot has a pooled security, a shared security, which gives you the option that everything would be okay. So practically the main idea of the Polkadot is to ensure the security of all the networks. So once we are launching Vara and stabilizing it and running it fast, the next stage would be to go into the Polkadot and Kusama ecosystem and launch the parachains. But we'll be also thinking about bridging there, so Vara will also be part of that great ecosystem. Second thing that we are also thinking a lot is about scaling adoption. If you will see the results of now, we'll see around 80,000 commits a month related to crypto. And this is mainly actually Solidity guys. If you will see a broader amount of people, like 2.2 million of developers that are coding on Rust, and actually Rust is the main language on which you can write smart contracts on Gear, for example, we have 2.2 million people. And as we are built on WASM, there is another, like 10 languages that are compilable with WASM. So you have 20 million of developers that actually could be coding in WASM. And then we have around 31 million of full stack developers around the world. All these guys are outside of the blockchain space. And the idea is to bring them into the blockchain space. Then we will really start having adoption. Because when we're talking about, and what's happening now with a lot of blockchains, the developers are just moving from one chain to another chain. So they have Near, then they go to Solana, then they go to Ethereum. Who else gives the bigger amount of grants? There they go. It really doesn't help a lot to spread the space. The idea is to bring new guys into here. And this is also our approach and how we do it. We built a lot of libraries on which you can actually, like plug and play, develop your applications. Meaning, we have videos where people can develop your DAO from zero into having a DAO with voting guides and stuff like that in less than 8 minutes. You can develop an NFT marketplace in less than 15 minutes. So it's easily fast and scalable solution for any developer. You don't need to know a lot of Rust actually to do it because everything is already like pre-built. Thanks to the libraries that we are doing, you can also have to handle 2 practical things: the message that you are sending to the program and the message that you're receiving out. But actually, we're a people-first company. We're around 40 persons that are really passionate about blockchain technology and decentralization. We really like the idea of sharing and building something amazing into the blockchain space. So if you are interested in collaboration, in having something and help us to build this space even bigger, please share us, send us, find us, write us, do whatever you think comfortable with that. Here's our links. Actually, the contract templates where you can see on our wiki all the examples with code explanations. We're also planning to launch our academy. Practically at the end of this month, we will be launching a free academy for every developer where you'll be guided step by step on how to write your smart contracts there. And plus, we decided to do something interesting. We decided to show you how actually the actor model can really interact with the user. Meaning, you will be building we will be explained into different examples on how step by step to build different type of contracts. But at the same time, you will have like a homework on which you will be building an NFT, but not a simple NFT. It will be an NFT with which you can be interacting. It sends you the message asking for something, you send him the message back, and depending on the result of the message, he can start growing, he can become sad, he can become laughable, whatever you want. It will depend a lot on that. So the idea of communication begins to give a lot of options into interaction with contracts. That's actually really interesting. So you have it here, you have our GitHub. It's actually totally open source. You can check what's happening there. You can review all the information, all the comments that the guys are doing. We're audited for the third company, Hot Hobart. We had an amazing result from them. We're also running or preparing to run a bounty hunt program. And you have our Twitter with all the news that we're posting, all the ideas and information, where we'll be announcing everything. And then you have Discord, actually, a lot of developers and our own developers are sitting there and writing day by day all the information regarding what's happening with the news. So I think on that stage, if you have any questions, for sure.
Could you please share with us how your protocol differs from Solidity language, or what you add to it?
Okay, how our protocol differs with Solidity language? First of all, we don't really use Solidity. Solidity is a language used with AVM virtual machine, virtual machine. We're using Rust as we're using Wasm virtual machine. It's like a language that's a computer-sized language built quite long. It's modern, it's really fast. It gives you a lot of syntaxes, examples on actually how all the errors that you're having. And this actually speeds up a lot also the applications and smart contracts that you can be running and doing into the blockchain space. You're welcome. Any other question? If not, thanks a lot, guys. I hope you liked the presentation and have a good day.